Okay, folks, this is an example problem for vertical circles. So you have a pail of water and it is going in a circle of radius, drew that too big, of radius 1 meter. So imagine there's like a string. We care about the water. So if you look at the water, and then sorry, it says what is the pail's minimum speed at the top of the circle if no water is to spill out. So not spilling out means that it stays in contact. So it means the normal is greater than or equal to zero, because it can be zero for an infinitesimal amount of time. And then because it has velocity, has inertia, the velocity is not zero, the normal force is zero. The bucket has turned and is now here, and then the water is going to slam itself into the bucket a split second later. If that doesn't make sense, ask me to talk about that in class. Okay, so sounds really complicated. Let's start with what we know, right? So it has weight towards the center of the earth, and it potentially has a normal force. I would encourage you to draw it that the bottom of the bucket is the water's literally inertia and like trying to fly off tangent. And so it literally slams itself into the bottom of the bucket there, which causes a downward normal. Okay, so we have the normal that is radially inward, and we have the weight that's radially inward. So they're both positive, which is good because in must win. Okay, it doesn't have to fight anything. I've got two forces helping me go in a circle. Okay, they're both pointing towards the center, so they're both helping turn. So again, I would suggest you pretend like the normal is there, and then you say, okay, let me read the problem. Oh, minimum speed means if I make that zero, I'm going to find the minimum, and I just need to make sure I go faster than that. Kind of like setting the sum of the forces equal to zero when you're just about to slide, like static friction, the minimum force you need to not slide down the wall. Okay, so we're going to set that equal to zero. And the force of the weight is equal to mg. And the reason they didn't give you the mass of the water is because it cancels. Because the more mass you have, the more inertia you have, the more it's trying to fly off tangent. That's this m over here. But the more mass you have, the longer the weight vector, the stronger the pull. And so it's a self-equilibrating system. I have more inertia, but I also have more force making me turn, so it doesn't matter what it is. Cancels. Okay, we are trying to solve for V, so let's plug in 9.8 for G. V squared, and R isn't, it's 1, so it just means V squared is 9.8. So V is the square root of 9.8, or 3.13 meters per second. Okay, so the trick is not spilling means I'm staying in contact. If the normal went to zero here, it means the water fell out here, right? So you've got to make sure that it's slamming itself into the bucket of water enough so that it could be zero for a split second here, because a minute later, an infinitesimal amount of time later, the bucket has turned, right? The bucket's going in a circle and the water is trying to fly off tangent here, which means it's slamming itself into the bucket, and then the normal exists again. Okay. Again, hopefully that makes sense. Please reach out if you have questions. Talk to your friends. Talk to your enemies. Talk to your teacher. And then it is your job to know whether you need to go faster than that or slower than that. Because and the trick is all about inertia. Okay, and then the last thing I'm going to say, I like to put the normal force in there even though we know we're going to set it equal to zero, because on my test, a classic problem is, find the minimum speed to not fall off, and then double that speed and then find what the normal really, find what the normal is at that point. So it's good to know which way it's going. But I won't take off if there is no normal and you don't draw it, then that's not wrong. Okay. Hopefully that makes sense. And thanks for listening. And I'll see you in class.